Welcome to the Crazy Hat Chemist. So another video in bonding and molecular structure. So let's get moving. Bam! So today we're going to be doing the whole thing. That is sulfur tetrafluoride's molecular geometry and oh, so much more. So sulfur tetrafluoride. So you should be able to get the formula of sulfur tetrafluoride. From sulfur, that's one sulfur. Tetra, that's for four, so that's four fluoride. So here is our formula for sulfur tetrafluoride. Then we're going to look on a periodic table and determine the number of valence electrons in each, and then the valence electrons total. Sulfur has 6, fluorine has 7. There are 4 fluorines. We're going to sum these numbers up. We're going to get 34 total number of electrons, but of course we're always using pairs. So we're going to divide this number by 2, and we're going to get the magic number 17 pairs. Now, the least electronegative element goes in the middle. That would be the sulfur. That's why that's in the middle. Then, the fluorines surround that sulfur in the X marks the spot pattern. Bam! Just like that. Now what we're going to do is we're going to place those 17 pairs of electrons equally around there. And so our first rule in placing electrons is to place electrons, a pair of electrons, so that you have a single or a sigma bond between the central element and the outside elements, and that is done right there. Now, do I have any more electrons left over? Oh, I most certainly do. So now these next set of electrons, pairs of electrons, go around the outside elements, and that is done like that. Okay? All right, those are lone pairs of electrons. Now, do I have any more pairs of electrons? I do. In fact, I have one more pair. Where is it going to go? What's the next rule? The next rule is to place pairs of electrons on this central element. And that is done just like that. Now, I'm going to ask myself, sulfur. I'm going to look for sulfur, find sulfur on the periodic table and ask, is sulfur period 3, 4, 5, 6, or 7? That is it period 3 or greater? Can it exceed the octet rule and be hypervalent? The answer is yes. So it is actually okay to place that pair of electrons on the sulfur because it is now exceeding the octet rule. We need to check for the octet rule for the fluorine because fluorine is period 2 and one of 4 elements which must obey the octet rule, and that is done like that. Now what we're going to do is we're going to clean up this Lewis dot structure here, make it look nice and pretty, and we're going to use the bonding pairs of electrons as lines, and that's what I've done right here. You should see that you have that central sulfur, you have 4 bonded, singly bonded fluorines, and a lone pair of electrons on that sulfur in the middle. Okay, now what we're going to do is we're going to figure out what the axe geometry of this is, the axe-like structure. There's one central element, that's the A, then the X's are the fluorines around, and then the E is that lone pair of electrons on the central element. So it's AX4E. Okay, now from this, how many bonding and how many non-bonding do you have? You have 4 bonding and 1 non-bonding. That leads to a particular name of a shape, whether it's AX4E or the 4 bonding, 1 non-bonding. And that particular shape name is disphenoidal or seesaw. Disphenoidal or seesaw. All right, now, with disphenoidal or seesaw, those bond angles are less than 90 and less than 120. Okay? That is, there is a compression of bond angles due to the lone pair of electrons on the central element. I'm going to show that to you in a model in just a second, so hold on to that. Okay, now we're going to get the hybridization. So it's S, P1, P2, P3, dehybridized. This is sp3 dehybridized. Okay, I'm going to show you this molecule right here. And here it is. You should see that right there. That is disphenoidal seesaw. Hopefully you see the seesaw. Here's the seesaw. That's what the seesaw is, right? Just like that. Okay? You got a lone pair of electrons on the central element, and that is within this trigonal planar structure here. Okay? Because the trigonal planar structure needs more angles. It has more angles. That's 120 as opposed to the 90, and that's why it's not at the poles. Okay, this lone pair of electrons compresses the bond angles. That's why this is less than 90. That's why this right here is less than 120. Okay, it's sp3 dehybridized. That means it's S, P1, P2, P3 dehybridized. That is, there are 5 domains around the central element. Now the next question is this molecule polar or nonpolar? It most certainly has polar bonds. That is, there is a difference in electronegativity between the sulfur and the fluorine. Now, is the molecule itself symmetrical or asymmetrical? That's the second part of the polarity question. And if it's disphonoidal or seesaw, it is most certainly asymmetrical. That is, this side is different than this side most certainly. Okay, or you could do it from top to bottom or bottom to top. It really doesn't matter. But it is asymmetrical, and since it has polar bonds and is asymmetrical, therefore that molecule is polar. And that's what we got with that right there. Hopefully that works out well for you. I'm going to give you a crazy hat here in just a second, so hold on. Hold on to your boats. There's a crazy hat. Look at that. I got a chicken. Poop! My head's in a chicken. Yeah, you know what. Okay, give me a thumbs up, subscribe to my YouTube channel, pass on my YouTube channel to all your friends who love chemistry, who want to learn chemistry the right way. Bye now. Have a great day.